Hello everyone, in this video we're going to talk about what is known as the rational root theorem. So let's jump right into a little bit of an example here in white. At the top of the screen we see 64x cubed plus 152x squared minus 62x minus 105 is equal to 0. Now I'm going to go ahead and tell you what the solutions to this polynomial equation is, or what they are. The solutions are negative 5 over 2, negative 3/4, and 7/8. Now let's look at these three solutions, and specifically their numerators and their denominators, and let's see what they have in common with the leading coefficient and with the constant term. All right, so now let's look at our numerators. Okay, our numerators, and let's not worry about the negative here, but we have 5, we have 3, we have 7. So if we notice, all three of our numerators are factors of our constant term. So like if we look at this and we said 105 divided by 5, and we did 105 divided by 3, and then we did 105 divided by 7, all of those are going to give us whole numbers because those are factors, okay? All right, so 105 divided by 3, we're going to get 35. 105 divided by 5 gives us a 21, and 105 divided by 7 gives us 15, right? So all three of our numerators were factors of our constant term. Now, if we look at our denominators, and let's go orange here, 2, 4, and 8, all three of our denominators are factors of our leading coefficient. So if we do 64 divided by 2, we get 32, 64 divided by 4, 16, and 64 divided by 8 gives us an 8. So now, what can we take away from this? Well, that brings us to what's in black here. And this essentially is our rational root theorem. It says if f of x is equal to a sub n x to the n plus, and then we have some information there in the middle, some other terms, plus a sub 1 to the x plus a sub 0, or essentially a polynomial equation or a polynomial function. If it has integer coefficients, then every rational solution of f of x equals 0, or basically trying to find the zeros of the function, has the following form. P over Q is equal to, so our numerators are going to be factors of our constant term, and our denominators are going to be factors of our leading coefficient. That's what the rational root theorem states. And now how can we use this? Well, in yellow it tells us what this does for us. This is going to allow us to list all possible solutions of the polynomial equation. Why? Because all we have to do is look at the constant and list the factors of it as the numerator, and the factors of our leading coefficient as the denominator. And that gives us all of our options. Now in this video we're focusing on when our leading coefficient is 1. Now in the example at the very top, our leading coefficient was 64. The example that we are going to do together, our leading coefficient is 1. And so in this case it's going to be a little bit easier. There's not going to be that many possible solutions. And in the next video that we're going to do on the channel, we're going to do an example where we have a leading coefficient other than 1, where there could be a lot more possible solutions. And that's where the graph of the function is going to come into play to help us out a little bit. So that'll be in the next video that we do. So once we find our possible solutions, we have to find our actual solutions, and we must test our possible solutions using synthetic division. So that's what we're going to do in this example that we see right here. So we want to find all real solutions of x cubed plus x squared minus 14x minus 24 equals 0. And really it's a three-step process. Step number 1, we want to list all possible rational solutions. So we do that by using the rational root theorem. We look at our leading coefficient, which is 1, and our constant term, which is negative 24 or 24. And we're going to be able to list out the factors of those numbers. And then step 2, we're going to test those possible solutions using synthetic division. And once we use synthetic division, if we get a remainder of 0, that tells us that the number that we're using on the outside of our synthetic division, that is a solution. And so then we're going to be able to factor completely using our result from our synthetic division process in step 2. So let's jump right in. So if we look back here at the top in black, it says our numerators should be factors of our constant term, and our denominators should be factors of our leading coefficient. Well, in this one, our leading coefficient is 1, so 1 is its only factor, right? So for step number 1, we could say x is equal to positive or negative, and so all of our denominators are going to be 1 because our leading coefficient is 1. And that's why it limits the number of solutions that we could have. And like I said, in this video, it's going to be not as many possible solutions as if our leading coefficient was something other than 1. So now let's look at our constant term. It's a 24. So if we think about it, okay, 1 is a factor of 24. And notice how I'm putting positive or negative in front of these. Okay, 2 is a factor of 24. 3 is a factor of 24. 4 is a factor of 24. 5 is not, but 6 is. 7's not, but 8 is. 9 is not, 10, 11, 12. Plus or minus 12 over 1. And then lastly, itself, so 24. Okay, so those are our possible solutions. So that's 2, 4, 6, 8, 10, 12, 14, 16 possible solutions. Now, we don't have to test all 16 of these, but we just need to test until we get an actual solution. And then once we do that, we can use that solution and the resulting information from our synthetic division process to allow us to factor to get our final solutions. So let's test some possible solutions. So let's just start with 1, right? So let's do 1 here. Let's do our synthetic division. And remember, we are using synthetic division up with our polynomial. So we have our coefficients are 1, 1, negative 14, and negative 24. So we always bring down our first term, and we're going to multiply on the diagonals and add on the verticals. So 1 times 1 is 1, 1 plus 1 is 2, 2 times 1 is 2. Negative 14 plus 2 would be negative 12. Negative 12 times 1 would be negative 12. And we add here, we get negative 36. So since this right here does not equal 0, then we know 1 is not a factor. Okay, so now we can forget 1. And how about let's move on to negative 1. Let's try negative 1. So we can erase what we have here. Could have left that first 1 there. And now let's see if negative 1 is a solution. So we're going to bring down our 1. This would be negative 1, 0, 0, negative 14, positive 14, and negative 10. So once again, does not equal 0, so we know negative 1 is also not a solution. Okay, so let's erase what we have here. All right, and now let's move on to positive 2. Okay, so now 2 times 1 is 2, 1 plus 2 is 3, 3 times 2 is 6. Negative 14 plus 6 would give us a negative 8. And then 2 times negative 8 would give us a negative 16. So now when we add here, we're going to get negative 40. So once again, does not equal 0. Okay, so now how about negative 2? Okay, so let's erase what we have here. Let's put our negative right here. So I'm bringing down our 1. Negative 2 times 1 would be negative 2. 1 plus negative 2 would be negative 1. Negative 1 times negative 2 would be 2. Negative 14 plus 2 would be negative 12, and negative 2 times negative 12 would be a positive 24. So finally, we get a remainder of 0, which tells us that negative 2 is one of our solutions. Okay, now think about what our binomial factor was that we were dividing by in order for us to get a negative 2 outside of our synthetic division. Well, what we did was we set x plus 2 equal to 0. Right? And that's how we got negative 2. So that means one of our factors is x plus 2. And now to get our other factor, we can look at what we have resulting from our synthetic division process. So remember, this is always our remainder, our constant, our linear term, and our quadratic term. So this is going to be an x squared minus x minus 12 as our trinomial factor. So now we can factor now the trinomial that we have. So we still have x plus 2. But now we just need to think about what two numbers add to negative 1 and multiply to negative 12. And that's going to give us negative 4 and 3, right? Negative 4 plus 3 would be negative 1. Negative 4 times 3 would be negative 12. So now we've factored, we have 3 binomials. We can now use the zero product property because remember, this is equal to 0, right? That's what we started with, equals 0. And so now we can just set each of these equal to 0. So we can say x plus 2 equals 0. So x equals negative 2 is one of our solutions. X minus 4 equals 0, so x equals 4 is one of our solutions. And x plus 3 equals 0, so x is also negative 3. So if we were to look at this polynomial function or equation, if we were to graph it as a function, then we would see it cross the x-axis at negative 2, negative 3, and 4. And that's the rational root theorem and how you can use it to find some possible solutions, test those possible solutions, to find the actual solutions of a polynomial equation.